Section 6.1 Interactive Assignment Objective 5. Suppose a life insurance company sells a $300,000 one-year term life insurance policy to a 25-year-old female for $270. The probability that the female survives the year is 0.999653. Compute and interpret the expected value of this policy to the insurance company. Okay, so here we have our question, and it says, because the mean of a random variable represents what is expected to happen in the long run, the mean of the random variable is also called the expected value. Now, there are two possible outcomes to the experiment, survival or death. We're going to let the random variable x represent the payout, money lost or gained, depending on survival or death of the insured. So we first need to assign probabilities to each of these random variables. So what we're going to look first is that we know in the question is that the probability that the female survives the year is given by 0.99653. So there is our probability. Now, since the sum of the probabilities must equal 1 or must be 1, we're going to subtract 0.999653 from 1 to find the probability of death. So what we're going to do is we're going to take 1 and then subtract the probability of survives, which is going to equal the probability of dies. So we know that from our question, we know that we're going to take the value of 1 and then we're going to subtract the probability that it survives. And so that's going to give us 0.000347. So it's just like finding the complement. So therefore, the probability of death is now going to be 0.000347. So we're going to need these probabilities to continue our problem. Now, we need to determine the payout for each possibility. Now, from the point of view of the insurance company, if the client survives the year, the insurance company makes the $270. Therefore, we're going to let X equal $270 if the client survives the year. Now, if the client dies during the year, the insurance company must pay $300,000 to the client's beneficiary. However, the company still keeps the $270. So what we're going to do is we're going to let the following. We're going to let X equal 270 minus the $300,000. So when we subtract that, we get negative $299,730. Okay, so now that we have this amount, what we want to do is we can see that the value is negative because it is money paid out by the insurance company. So we're going to create a distribution table. So we have the value of X, we have the probability, and then we're going to take the value of X and then multiply it by its probability. So the first thing we need to look at is the probability of survival. So remember that X represents $270 of survival. So we're going to take 270 and multiply it by the probability. So if we take 270 and multiply it by 0.999653, it gives us 269.90631. Okay, and then the next thing we're going to do is we're going to take the value of the probability that we found for X, which was negative $299,730, which represents the probability of the value of X of death. We're going to multiply it by the probability that we found of 0.00347. When we multiply those two values together, we get negative 104.00631. Now, in order to find the expected value, we need to find the total of this last column. So to find the expected value, it's also equal to the mean. So we're going to find the sum of these two values. So we're going to add these two values. So 269.90631 plus negative 104.00631 gives us the expected value of $165.90. So then we would say that the insurance company expects to make an average profit of $165.90 on every 25-year-old female it insures for 1 year. Going back to our problem, we can see what we get for the answer here. Again, the expected value is $165.90. And then which of the following interpretation of the expected value is correct? Well, if we go down a little further here, we will see that the insurance company expects to make an average profit of $165.90 on every 25-year-old female it insures for 1 year.